Hi students, welcome to Sunil's tutorial. I am Sunil Melwani and today we will be doing the numericals of elasticity. Take down the first sum guys, start writing. I'll dictate the sum, you all have to write the sum guys. Calculate the Poisson's ratio for silver. Calculate the Poisson's ratio for silver if Young's modulus is 7.25 into 10 raised to 10 meters, if Young's modulus is 7.25 into 10 raised to 10 newtons per meter square, and bulk modulus is 11 into 10 raised to 10 newtons per meter square. If Young's modulus is 7.25 into 10 raised to 10 newtons per meter square and bulk modulus is 11 into 10 raised to 10 newtons per meter square. Guys, the formula that you will have to use is, they've asked you to find out Poisson's ratio. Remember I told you what is the relationship between various modulus. You will have to use the formula Young's modulus is 3 times bulk modulus 1 minus twice Poisson's ratio. So therefore I can say that y upon 3k is 1 minus 2 sigma. Therefore you would say that 2 sigma is 1 minus y upon 3k. So I can say 2 sigma is 3k minus y upon 3k. Therefore you would say sigma is 3k minus y upon 6k. You have the values, you should be able to substitute and get this answer. The answer for this sum guys should be 0.39. I'm not going to solve the sum, I'll show you the method, formula, substitution and solving you should be able to do on your own. Next, take on the next sum please. For a given material, Young's modulus is 2.4 times the modulus of rigidity. Young's modulus is 2.4 times the modulus of rigidity. Find Poisson's ratio. Find Poisson's ratio. Now guys, we have done this ratios between the various modulus. I can say that modulus of rigidity is Young's modulus upon twice 1 minus Poisson's ratio. Cross multiply, I can say that 1 minus Poisson's ratio is Young's modulus upon twice modulus of rigidity. 1 minus y upon 2n is sigma. So I can therefore say sigma is twice modulus of rigidity minus Young's modulus upon twice modulus of rigidity. You have all the values, you can substitute y as 2.4n and you should be able to get the answer. Okay, this is not minus, this should be plus guys. Please make the correction there. This should be plus, so in that case this is plus. So in that case this will be y. This will be sigma is equal to y upon 2n minus 1. Sigma is y minus twice n upon 2n. This will be the formula guys. Okay, so your answer should be y minus twice modulus of rigidity upon twice modulus of rigidity. You can substitute the value of Young's modulus as 2.4 modulus of rigidity. You should get the answer for this sum. The answer for this sum should be 0.2. Right? Take our next sum please. The elastic limit of copper is 1.5 into 10 raised to 4 newtons per meter square. The elastic limit for copper is 1.5 into 10 raised to 4 newtons per meter square. Find the minimum radius. Find the minimum radius of a copper wire find the minimum radius of a copper wire. Find the minimum radius a copper wire must have if its elastic limit is not to be exceeded under a load of 20 kgs. Right? Now mass is given to you. I can find out F. F is equal to mg. So 20 into 9.8 newtons. This is going to be my force. Right? Elastic limit is nothing but force per unit area. Right? Since this is a wire, the cross sectional area of the wire will be a circle. So this is F upon pi r square. Therefore, I can say that r square is F upon pi e. Therefore, r is square root of F upon pi e. Right? You have all the values, you can substitute. You have the value of F, pi and E. F is mg, pi you know is 3.14, E is given to you. You should be able to get this answer. The answer should be 6.45 into 10 raised to minus 2 meters. Next, take on the next one please. What would be the greatest length? What would be the greatest length of the steel wire? What would be the greatest length of the steel wire which when fixed? What would be the greatest length of the steel wire which when fixed at one end can hang freely without breaking? Which when fixed at one end can hang freely without breaking if the density of steel is 7800 kgs per meter cube and the breaking stress of steel is 7.8 into 10 raised to 8 newtons per meter square. Now guys, they've given you density. First of all, let's try to use density. Density is nothing but mass upon volume. Density is mass upon volume. Volume can be written as area into length, right? Therefore, I can say that mass is density into area into length, right? I can say that the mass is density into cross-sectional area into the length of the conductor or the length of the wire. Okay, once you have this, then let's try to find out I can say that stress is nothing but force upon area. Stress is force upon area. Force is nothing but mg upon area. M you just found out is rho al. Rho al g upon A. A and A gets cancelled, so this will be rho L G. So it will be equal to the density, the length and the gravitational force, right? Density you know, mass is given to you, no, stress is given to you. Stress is given to you. What have they asked you to find out? What is the greatest length? So I can say L is equal to stress upon rho g. Stress I know, rho I know, g is 9.8. You will come to know the length of the conductor, the length of the steel wire, right? The answer for this sum should come to 1.02 into 10 raised to 4 meters. Next, take down next sum please. A wire of length 3 meters, a wire of length 3 meters and diameter 2 millimeters, a wire of length 3 meters and diameter 2 millimeters when stretched by a load of 6 kg weight, when stretched by a load of 6 kg weight, F is 6 kg weight, so mass will be 6 kg guys, extends by 1 millimeter. Determine the Young's modulus. Determine the Young's modulus of the wire. Now, first of all, if diameter is given to you as 2 millimeters, you can find out the radius. I can say radius R will be 1 millimeter. Radius is half the diameter. Convert from millimeters to meters. How do you do that? Multiply by 10 raised to minus 3. Extension is 1 millimeter. Again converted into meters. How do you do that? Multiply by 10 raised to minus 3. Okay. You have length, you have radius, you have mass. Right? I can find out Young's modulus. Young's modulus is mgl upon pi r square L. We've derived this formula. Right? You know m, g is 9.8, you know the length, you know radius, you know the extension. You should be able to get the answer. Simple straightforward multiplication. Answer for this should be 5.618 into 10 raised to 10 newtons per meter square. Next, take on next sum please. There are two wires of the same material. There are two wires of the same material. The radii, there are two wires of the same material. Their radii and length are in the ratio of, their radii and length are in the ratio of 1:2. Their radii and their length are in the ratio of 1:2. If the extension produced are equal, if the extension produced are equal, if the extension produced are equal, what is the ratio of the load? What is the ratio of the load? Now, since the wires are made of same material, they will have the same Young's modulus. Okay. Ratio of the radii, ratio of the length and the extension, everything is given to you. Now we know that Young's modulus is nothing but mgl upon pi r square L. So Young's modulus 1 is going to be this, right? Similarly, Young's modulus 2 of the second wire will be M2G L2 R2 square L2. Divide the two equations. If I divide, then I can say Y1 upon Y2 is M1 upon M2, right? I'm dividing this. G and G will get cancelled. L1 upon L2. Then denominator of denominator becomes numerator. R2 upon R1, the whole square, and L2 upon L1. Right? But they've asked you to find out the ratio of the load. That means they've asked you to find out M1 upon M2. Therefore, you can say that M1 upon M2 is nothing but Y1 upon Y2 into L2 upon L1 into R1 upon R2 the whole square into L1 upon L2. Substitute the values, you have all the values given to you, in which case you should get the answer for this as 1:2. Right? Take down next one please. A steel wire has a diameter of 2 millimeters. A steel wire has a diameter of 2 millimeters and length of 3 meters. A steel wire has a diameter of 2 millimeters and length of 3 meters. It is stretched by applying a force of 5 kg weight. It is stretched by applying a force of 5 kg weight. That means in that case my mass is going to be 5 kg. Find the increase in the length of the wire. Find the increase in the length of the wire, strain and stress. Find the increase in the length of the wire, strain and stress if the Young's modulus for steel is 20 into 10 raised to 10 newtons per meter square. If Young's modulus for steel is 20 into 10 raised to 10 newtons per meter square. Now first of all, they've given you diameter is 2 millimeters. So I can say that radius is 1 millimeter, which is 1 into 10 raised to minus 3 meters. So I come to know my radius. Okay, let's move on ahead. They have asked me to find out Young's modulus. Young's modulus is nothing but mgl upon pi r square L. I know the mass, G I know, length of the wire is given to you, radius is known, extension you have to find out. Young's modulus is given to you. Therefore, I can say L, extension is nothing but mgl upon pi r square y. Okay, that was the first part of the question. Next, second part of the question. This was the first part of the question. Second part of the question, they have asked you to find out strain. Guys, from definition we know that strain is nothing but change in length upon original length. Strain is nothing but change in length upon original length. You know small n, you know capital N, you should get this answer. And the third part of the question, they have asked you to find out stress. Stress, how do I find that out? I can find that out by using the formula. Young's modulus is nothing but stress upon strain. Young's modulus is nothing but stress upon strain. Fine, do we get this thing clear? So in that case, I can therefore say that stress is equal to Y into strain. Right? Do you get this in here? So you will get the value of stress here. The answer for this sum should be L, you should get as 2.34 into 10 raised to minus 4 meters. Strain, you should get as 7.8 into 10 raised to minus 5. And stress, you should get as 1.56 into 10 raised to 7 newtons per meter square. Those are the values that you should get, right? Take on next sum, please. An aluminium wire and a steel wire, of the same length, an aluminium wire and steel wire of the same length and cross-sectional area of the same length and cross-sectional area are joined end to end. The composite wire is hung from a rigid support. The composite wire is hung from a rigid support and a load is suspended from its free end. If the increase in the composite wire is 5.4 millimeters, if the increase in composite wire is 5.4 millimeters, find the increase in the length of each wire. Find the increase in the length of each wire if the Young's modulus for steel is nothing but 2 into 10 raised to 11 newtons per meter square, and Young's modulus for aluminium is 7 into 10 raised to 10 newtons per meter square. Young's modulus for steel is 2 into 10 raised to 11 newtons per meter square, and for aluminium is 7 into 10 raised to 10 newtons per meter square. Right? Now, I can say that we know that Young's modulus is nothing but mgl upon pi r square L. Right? So I can say that Young's modulus for steel is going to be mgl upon pi r square L for steel. Similarly, Young's modulus for aluminium will be mass of aluminium, same load is connected. So mass is going to be same. G is going to be same. Length of aluminium, pi r square of aluminium and length of aluminium. Okay. So in that case, I can say that Young's modulus of steel upon Young's modulus of aluminium, mg gets cancelled. So you will get length of steel upon length of aluminium. Denominator of denominator becomes numerator. Extension of aluminium upon extension of steel. Right? So therefore I can say that, but they've given me that length of steel is equal to length of aluminium. Therefore I can say Young's modulus for steel upon Young's modulus for aluminium is extension of aluminium upon extension of steel. Therefore, I could say that extension of aluminium is Young's modulus of steel upon Young's modulus of aluminium into length of steel, right? But they have given you that the composite length has increased by 5.4 millimeters, right? That means my length of aluminium plus, extension of aluminium plus extension of steel is 5.4 millimeters, converted into meters is 10 raised to minus 3. Now, length of aluminium can be substituted as Young's modulus of steel, Young's modulus of aluminium into length of steel, extension of steel plus extension of steel is 5.4 into 10 raised to minus 3. Now, here you could take LS common, so you get YS upon YAL plus 1 is 5.4 into 10 raised to minus 3. You know YS, you know YAL, you can substitute and get the answer. Here you should get steel, increase in the length of steel wire, answer, increase in the length of steel wire should be equal to 1.4 millimeter, and increase in the length of aluminium wire should be 4 millimeters. And is the answer that you should get for this question. Right? Let's move on to the next one, guys. A brass wire of length 5 meters, a brass wire of length 5 meters and cross section area 1 millimeter square and cross section area 1 millimeter square, which can be written as 1 into 10 raised to minus 4 meter square, no, 10 raised to minus 6, because when you are converting from millimeters to meter, it is 10 raised to minus 3, so meter square will be 10 raised to minus 6, you square the thing. A brass wire of length 5 meters and cross section area 1 millimeter square is hung from a rigid support with the brass weight of volume 1000 centimeter cube, right? 1000 centimeter cube. When you are converting from centimeter to meter, it is 10 raised to minus 2. So this will be 10 raised to minus 6 meter cube. 1000 centimeter cube. I'll read the sum again, guys. A brass wire of length 5 meters and cross sectional area 1 millimeter square is hung from a rigid support with the brass weight of volume 1000 centimeter square hanging from the other end. Find hanging from the other end. Find the decrease in the length of the wire. Find the decrease in the length of the wire when the brass weight is completely immersed in water. When the brass weight is completely immersed in water. Fine, do we get this thing here? Please write this quickly. When the brass weight is completely immersed in water. Fine. If the Young's modulus for brass, is 10 to the power of 11 newtons per meter square, if the Young's modulus for brass is 10 to the power of 11 newtons per meter square. Guys, let's visualize what's going on in the sum. Rigid support, you have a brass wire, you have a brass weight. Okay, the length of the wire is given to you as 5 meters. This brass weight has a volume of 1000 centimeter cube. They are saying that this is immersed in water. Right? Now guys, we all know Archimedes principle. Archimedes principle states that when a body is immersed in water, partially or wholly, it loses weight. So that means this body is going to lose weight because it has been immersed in water, right? Now when a body is immersed in water, it loses weight. The loss of weight is equal to the water displaced by the immersed part of the body. Now let's see this. If it loses weight, then the extension will reduce. Now, let us assume that F is the force on the wire when the brass weight is not immersed in water. Weight not in water. And let us assume that F1 is the force on the wire when the weight has been immersed in water. Okay. Now we also know that density of water is 1 gram per centimeter cube, which is also equal to 1000 kgs per meter cube. Fine. Volume of the water displaced is equal to the volume of the water displaced they gave you is 1000 centimeter cube, which we have already converted. So in that case, how much is the loss of weight in water? The loss of weight in water is F minus F1, right? Now loss of weight in water by Archimedes principle is equal to the weight of the water displaced. Therefore I can say that F minus F1 is equal to weight of water displaced Now how much water is displaced, you will come to know. Weight of the water displaced. Weight is nothing but density into volume into G, right? Weight is nothing but density into volume into G, right? Density of water I know, volume I know, G I know. I'll come to know how much is the loss of weight in water. Now let us assume, let L and L1 be the extensions when body, that is your brass weight, is not and immersed in water. Now by Young's modulus I can say Y is equal to mgl upon pi r square L, which is nothing but AL. Now mg can be written as F, so therefore I can say that L1 is FL upon AY, right? So this can be written as L is equal to FL upon AY. Similarly, I can say that L1 is nothing but F1L upon AY. The length of the wire, original length of the wire is same, cross section area is same, Young's modulus is same because the same wire is being used. So in that case, the decrease in length of wire L minus L1 is nothing but FL upon AY minus F1L upon AY. So this is nothing but F minus F1 L upon AY, right? Out of which I know the value of F minus F1, L is given to me, A is given to me, Y is given to me. I'll come to know how much is the decrease in the length of the wire, right? You should get the answer for this sum as 0.49 millimeters, right? Take down next sum please. Find the longitudinal stress. Find the longitudinal stress. Find the longitudinal stress to be applied to a wire to decrease its diameter. Find the longitudinal stress to be applied to a wire to decrease its diameter uniformly, to decrease its diameter uniformly by 5%. To decrease its diameter uniformly by 5% if the Poisson's ratio, if Poisson's ratio is 0.3 and Young's modulus is 3 into 10 raised to 11 newtons per meter square, and Young's modulus is 3 into 10 raised to 11 newtons per meter square. Right? Let's try to do this sum, guys. Now, what is lateral strain? Lateral strain is nothing but the change in diameter upon original diameter. I can say that, guys, from here, if I take this d down, I'll get lateral strain is 5 upon 100. Right? Do we get this thing here? Poisson's ratio is given. Now, I can say that Poisson's ratio is lateral strain upon longitudinal strain. Lateral strain upon longitudinal strain. Lateral strain I know, Poisson's ratio I know, so I can find out longitudinal strain. Guys, I can say that therefore longitudinal strain is nothing but Poisson's ratio, is nothing but lateral strain upon Poisson's ratio is equal to lateral strain upon Poisson's ratio. Once I know what is longitudinal strain, then I can apply Young's modulus. What is Young's modulus? Young's modulus is nothing but longitudinal stress upon longitudinal strain. Young's modulus is longitudinal stress upon longitudinal strain. We also know that Young's modulus is nothing, longitudinal stress is nothing but force per unit area. Longitudinal strain is nothing but the change in length upon original length. Therefore, I can say that if I cross multiply, I'll get longitudinal stress is YL upon L is longitudinal stress. YL is nothing but longitudinal strain. So therefore I can say that longitudinal stress is nothing but Y into longitudinal strain. I could have directly also done it, but I wanted, since we are practicing here in the class, I want you to know the formulas thoroughly. Therefore, to recap the formulas, I did this. I could have directly multiplied the longitudinal strain here. Some of you can do that and get the answer, right? Answer for this should come out to 5 into 10 raised to 10 newtons per meter square. Next, let's see the next one, guys. Calculate the stress applied to a wire. Calculate the stress applied to a wire having mass per unit length having mass per unit length of 0.2 grams per centimeter, density of 8 grams per centimeter cube, when 15 gram weight is attached to its free end. If 15 gram weight is attached, that means mass is going to be 15 grams. Right? Now let's see this. I can say that density is mass upon volume. Density is mass upon volume. Therefore, I can say that mass is density into volume. Mass per unit length is nothing but mass upon length. But mass, I just found out, is nothing but density into volume. Mass per unit length is given to you as mass per unit length 0.2. Mass can be written as density into volume upon length. 0.2 is density. Volume is nothing but area into length upon length. Therefore, I can say here in this particular case, area is 0.2 upon density. Now, what have they asked me to find out? I'll come to know the area. Once I have the area, then I can find out. They've asked you to find out stress. Stress is force upon area. Force is given to you. Area you just found out. Substitute and get the answer. You will get this answer as 5.88 into 10 raised to 5 dynes per centimeter square. Right? Next, let's see the next one, guys. Two wires of the same material. Two wires of the same material. Two wires of the same material have their diameters in the ratio of 5:3. Have their diameters in the ratio of 5:3. Their lengths in the ratio of 2:3, and the stretching force in the ratio of 5:7, and the stretching force in the ratio of 5:7. Find the ratio of their extensions. Find the ratio of their extensions. Okay, let's see this. Young's modulus is nothing but FL upon AL, right? A is pi r square. R is nothing but diameter upon 2. So I can say Y is equal to FL upon pi diameter upon 2, the whole square into L, right? Therefore, I could say that length is equal to FL upon pi d square upon 4 into Y. So you could therefore say that L1 is 4 FL upon pi d square Y, right? Now what have they asked you to find out? They have asked you to find out the ratio of the extensions. If L1 is this, so here I can put everything as 1, right? Now similarly I can say that L2 is 4 F2 L2 upon pi D2 square upon Y2. Divide equation 1 and 2. If I divide equation 1 and 2, that's the above two equation, I'll get L1 upon L2, 4 and 4 gets cancelled, I'll get F1 upon F2, L1 upon L2, denominator of denominator becomes numerator, so this will be D2 the whole square upon D1 the whole square, and Y2 upon Y1. Pi and pi also gets cancelled, right? Here in fact Y2 and Y1 will also get cancelled because Y1 is equal to Y2. Therefore I'll get L1 upon L2 is F1 upon F2 into L1 upon L2 into D2 upon D1 the whole square. I presume all the values are given to you, so you should come to know the answer. The answer for this, when you solve this, should be 6:35. Right? Do we get this? Okay. We will stop this here for the day. Thank you very much.